From this presentation onwards, we will start with a new topic called pointer arithmetic. And in this presentation, we will see what happens when we add an integer to a pointer. So let's get started. Suppose we have a pointer P and we have an array A. I want to point to the first element of this array using this pointer P. Now my question to you is that what code I have to write in order to point to the first element of this array using this pointer P? I'll give you 10 seconds to answer this question and your time starts now. Stop. The answer to this question is P equals to ampersand of A0. A0 means first element of the array. We want to get the address of this first element of the array. Therefore, I'm placing ampersand in front of this A0. This gives us the address, that is the base address of the first element of the array. And the base address will get stored in the pointer P, which means that P will simply points to the first element of the array, right? Now, what happens if we add some integer to the pointer? Let's say we want to add 3 to the pointer P. P initially contains the address of the first element of the array. If we add 3 to it, what does it really mean? It means that we simply move the pointer 3 positions in forward direction. If we add an integer 3 to a pointer, it means that we will move the pointer 3 positions in the forward direction. You must have to note the initial position of the pointer. Here in this case, pointer is pointing to the first element of the array. Now what we have to do is, we simply move this pointer 3 positions in forward direction. 1, 2 and 3. So this is the place where this pointer will land. Let's see what does it mean in general sense. Initially, if P points to AI, that is the element of the array at index I, then P equals to P plus J is equivalent to address of AI plus J. If this general case seems difficult to you, let's get back to our example. If P points to A0, then P equals to P plus 3 is equivalent to address of A0 plus 3. Remember, this 0 is the index I and this 3 is this J integer which you are adding to the P pointer. What you basically have to do is simply add this integer 3 to the index where the pointer P initially points to. Here in our example, P points to the first element of the array. That is, it is at index 0. Just add 3 to it. It gives us value 3. Pointer simply lands at that index. And this is what happens when we add an integer to a pointer. Address of A0 plus 3 is equivalent to address of A3. That is, the address of the fourth element of this array, right? Now this is very simple to understand. I gave you the idea what happens when we add an integer to a pointer. Now let's see what happens behind the scenes. Suppose the base address of this array is 1000, and we will also assume that an integer will take 4 bytes of memory location. It simply means that if the base address of array is 1000, then first integer will get stored from address 1000 to 1003, and the next integer will get stored from the memory location 1004 to 1007 and so on, right? If base address of this array is 1000 and initially pointer P points to the first element of the array, it means that P will contain the base address, that is 1000. When I'm saying P contains the address of the first element of the array, it will take the base address of that memory location, that is 1000. So P will contain the address 1000. Now, if we add an integer 1 to it, then what will happen? We cannot simply add 1 to 1000. It will just give 1001. But we know the meaning of P equals to P plus 1. P equals to P plus 1 means the pointer has to move 1 position in the forward direction. That means it has to point to the next element of the array. And we know the base address of the next element of the array is 1004. Simply adding 1 to 1000 will not give the answer. We have to multiply 1 by 4 in order to get the base address of this element, that is 1004. So we cannot simply add 1 to 1000. This is what we should remember. We must multiply 1 by 4 and then add it to 1000. It is simple to understand. Next element is not stored in 1001. Each integer takes 4 bytes of memory location. Therefore, 4 needs to be multiplied by 1. It is important for us to understand how many bytes will an integer will take, and we should multiply those many bytes with the integer. Okay? If we know that integer will take 4 bytes of memory location, then we should multiply 1 by 4 and add it to the address. It gives us 1004, which is the base address of the second element of the array. Now if we say that we want to add 3 to pointer p, then we know the answer. We will multiply 3 by 4 and add it to 1000, which gives us 1012, which means pointer p will simply point to the fourth element of the array. So now you got the basic idea. Here's a healthy tip for you. Don't bother about the addresses unless explicitly asked. Now here's a homework problem for you. Let's say we have a pointer p and an array A. Initially p contains the address of third element of the array, that is p equals to ampersand of A2. What will be the index of the array after this operation, that is p equals to p plus 2? Here in this case you don't have to bother about the addresses. I'm not asking about the address in this question. I'm just asking about the index. Therefore, you don't have to bother about the addresses at all. Okay? Leave your answers in the comment section below. Okay friends, this is it for now. Thank you for watching this presentation.